Hey, welcome back to Math with Patrick. It's May 25th, and we're solving problem number 145 from the Daily Epsilon calendar. And we need to show why x is 25 today, because that's today's date. So it looks like I have two variables. I have x and I have y. And when I square root them both and then add those values together, I get 9. And then also when I take the difference of the values, I still get 9. The first thing I'm noticing is that x and y are probably non-negative because square rooting negative numbers is kind of an issue. I mean, it'll create like an imaginary or a complex number, but I just don't think we're going to be using that today. And then next, the difference is always 9 between the two. And so I can generate a few pairs of x and y that like follow this rule that are still non-negative. Like the first one that comes to mind is like 9 and 0, right? Because 9 minus 0 is still 9. They're both non-negative, so I can square root them both. Although when I do root 9 plus root 0, that's 3 plus 0, or just 3. And so this number isn't yet at 9. The next number that might make sense for me to check would be like the next square number after 9. And so that's going to be 16. And so since I added, let's see, 7 to that number, I should probably add 7 to this number. And then so their difference, 16 minus 7 is still 9. And then the sum of the roots, well, I don't really know what root 7 is off the top of my head. I do know it's between 2 and 3, because 2 squared is 4 and 3 squared is 9. And so adding the square roots together, I'll get 4 plus 2 point something. So this is going to be like 6 point something, still not close to 9. I could try the next square number for x, which is 25. And then when I subtract 9 from that, I will get 16. This is looking pretty good because 25 minus 16 still is 9. And then when I take the square root of both and add them together, I get 5 plus 4, which is equal to 9. So cool. Actually, with just a little bit of guess and check, I'm able to figure out that x is equal to 25. Maybe we should try a slightly different strategy because guess and check won't always work for all problems. Maybe let's also try to solve it like algebraically or maybe graphically actually, just to make sure that this is like the one and only one solution. So I don't know if this is really going to work, but I want to try solving it algebraically. One thing that I'm seeing here is that I could probably get rid of these square roots, or not get rid of them, but kind of move them around a little bit. So we were initially given root x plus root y equals 9. And I am going to multiply both sides of this equation by root x minus root y. So it's a little bit silly to do this, I suppose, because all I'm really doing is moving the roots to over here. And maybe it looks kind of weirdly complex over here, but my goal was to kind of simplify the left side. Just distributing everything, I'm going to get x, or root x times root x is just x. And then I'll get a minus root xy, and then plus a root xy. So these middle terms cancel out when I'm doing all the distribution. And so I'm just left with x minus y is equal to 9 times root x minus root y. And then from this, maybe I could sub in x minus y. I know that's equal to 9. So I have 9 equals 9 times root x minus root y. And I'm left with, well, if I divide both sides by 9, I'm left with 1 is equal to root x minus root y. And maybe this lines me up nicely to do a little system of equations with that top one again, where I could just rewrite root x plus root y here. That's equal to 9. And maybe I could add both equations together. And I can kind of keep it balanced. This is like a strategy called elimination, where you are allowed to add the left side or subtract of this system and set it equal to the other side of the system of equations also added. So the 1 plus 9 makes a 10, and I'm going to keep that balanced by adding these together. The negative root y and the positive root y cancel out. That's the elimination idea. And I'm left with 2 times root x. That shows me that root x has to be equal to 5. And then if we square both sides, that shows me that x has to be equal to 25. So there's an algebraic way to also confirm that x equals 25 is our only answer. Finally, we can just graph it and see what it looks like. I think it'll be easier to start with x minus y equals 9. That's just going to be a straight line. And earlier we found some values that worked for this equation, like the 16 and the 7. And so this point being on the line just represents that those values satisfy this condition, x minus y equals 9. And so when I type the other one, I'm going to get some kind of curve probably. And oh, there it is. And so any point along this curve is going to satisfy the second equation. And the only time that both equations are satisfied is right here, which, yeah, was our 25, comma 16. So graphing it, you can really see that there's only one spot that these two curves, or the curve and the line, are ever going to intersect, and it's specifically when x is 25. So there's 3 different ways to confirm that the one and only answer today is 25, and I'm feeling pretty good about this problem. So thanks for solving this with me, and I'll see you tomorrow. Bye-bye.